Alright, today we're going to be talking about ratio tables. So that's our title. And this is on page 38 in our notebooks. Don't forget to be keeping up with your table of contents. And it says you can use ratios to create a graph. When ratios are equivalent, they will produce a straight line. Okay, when ratios are equivalent, they will produce a straight line. So it says to use the table to create a graph. So we have an x value and a y value. Anytime we're looking at a coordinate plane, and this is just a fourth of the coordinate plane, this is just the positives on our coordinate plane. Our y-axis is up here. It goes up and down, it's vertical. And our x-axis is horizontal. So all of our x's will be put down here, all of our y's will be put up here. So we need to go from 2 to 10. So let's see. We can't go by ones, so 2, 4, 6, 8, 10, 12. We can go by twos. So we're going to label these 2, 4, 6, 8, 10, 12, 14, and 16. And then vertically, we need to go from 4 to 20. So we can't do it by ones. 2, 4, 6, 8, 10, 12, 14, 16. We can't do it by twos. So let's see. 3, 6, 9, 12, 15, 18, 21. That we could go by threes. So 3, 6, 9, 12, 15, 18, 21, 24. So the way this works is when x is 2, so down here on my x-axis, when x is 2, y is 4. So that's going to be about right here. When x is 4, y is 8. So that's about right here. When x is 6, y is 12. And when x is 10, y is 20. Okay, so I like to use a ruler to see, are these forming a straight line? Yes, they are all touching my ruler. So if I create my line, I'm going to go all the way through, and we're going to assume that this line keeps going, so we put an arrow on the end of it. So are all of these ratios, 2 to 4, 4 to 8, 6 to 12, 10 to 20, are all of those equivalent? Yes, because it forms the straight line. So we're going to say all ratios are equivalent. All right, moving on. It says for every 3 minutes, that Jesse spends reading. He reads 2 pages. Create a table of equivalent ratios. Then plot the ratios on the graph. Okay, so it says for every 3 minutes, he reads 2 pages. So 3 and 2 would be our first ratio. Then I would say let's multiply both of these by 2. That would give us 6 and 4. Multiply both of these ratios by 3. That would give us 9 and 6. And multiply this ratio by 4. That would give us 12 and 8. So in this situation, X is minutes read. X is our dependent variable, meaning that, our independent variable, meaning that it's independent. It doesn't rely on anything else. Minutes, time, that's something that's independent. It doesn't rely on anything else. It keeps going no matter what. Y is our dependent variable. The amount of pages he reads depends on how many minutes he's been reading. So you can see that relationship between our pages and minutes and our X and our Y. So again, X goes down here, Y goes up here. And let's go ahead, let's see, we need to go from 3 to 12. 1, 2, 3, 4, 5, 6, 7, 8. So let's go by 2s. And the label on this axis is going to be minutes. And on our y-axis, we need to go from 2 to 8. 1, 2, 3, 4, 5, 6, 7, 8. We could go by 1s. And this label is going to be pages read. Now, if I had to label this entire graph as a whole, we could just label it Jesse's reading. So for 3 minutes of reading, which is going to be right here, he would read 2 pages. For 6 minutes of reading, 4 pages. 9 to 6. And 12 to 8. So once again, I'm going to use my ruler. All of them are touching our line. All the way straight through. I'm going to put on an arrow so we know it keeps going. And we can see that they're all equivalent because they form that straight line. And that about does it.